Okay, guys. Great. Okay, great. So there are some limits that you'll need to know. Okay, so if a function limit as x goes to infinity of e to the s is plus infinity, is 0. So e to the negative infinity is 0. Now we have a few more. Okay, these are the limits that you need to know. So let's give an example. So I don't know. What is that? Where does the inside go to? Everybody. Arctan of positive infinity is? Okay, arctan is a continuous function. Well, arctan we also write it as tan inverse, okay? Let's use the other notation. What is that? As x goes to 0 plus, where does ln x go to? Negative infinity. Arctan of negative infinity is minus pi over 2. Okay? Great. Now, up to the new part. And vertical asymptotes. Let's start with the definition of vertical asymptotes. The line x is equal to a is said to be a vertical asymptote to the curve y is equal f of x if at least one of the following holds. Let me write them here. Of course, here by definition, I am assuming that we can define the notion of limits the line, the vertical line x equal a, the vertical asymptote, the curve y equal f of x, if one of these six limits holds. And let's give an example. And consider this function. Okay? Let's say this is a line y equal 1. What is f of 0? Everybody? F of 0 is what? What is the limit as x approaches 0 plus of f of x? What is that? Everybody, what is that? Positive infinity. So the line x equals 0 is a vertical asymptote to y equals f of x. Okay, it's not necessary that both, that you know that both sides of the limit do not exist. Okay? Everybody, are we good? Yeah? Let's give one more example. Let me write. What do you want? Give an example. What are the vertical asymptotes to 1 over x? To the curve y equal 1 over x, what is the vertical asymptote? Yeah? X equals 0. Can I have another vertical asymptote, or the limit of 1 over x as x approaches a non-zero a, it's 1 over a, right? So the only possibility is that x equals 0, and indeed plus infinity. So x equals 0 is a vertical asymptote to y equals. Okay, great. Let us look now at the definition of a horizontal asymptote. The line y is equal to L is a horizontal asymptote to the curve y is equal f of x at plus infinity or at minus infinity if the limit as x approaches infinity of f of x is equal to L, or if it's at minus infinity, okay, great. Very good. Now, what are the vertical asymptotes, the horizontal asymptotes to the curve y equal 1 over x? What is the limit? To find the horizontal asymptote at x equal infinity, I just have to look at the limit as x approaches, as x goes to plus infinity of 1 over x, and I get 0. And if x goes to minus infinity, okay, it's recording. I didn't check if it's going up. Okay. So the line y is equal to 0 is a horizontal asymptote to y equal 1 over x at infinity and minus. Okay, I mean, let's sketch what the horizontal asymptote may look like. Okay? Any questions? Easy to start. Yeah. Questions? No questions? All good? Yeah. And later on we'll see oblique asymptotes. Okay? Like when a line is an asymptote. Let's do an example. Okay, now find the asymptotes, find the vertical and horizontal asymptotes to the curve. Who wants to give me that favorite number? Raise your hand, raise your hand. Yep. 6, okay. Someone else? Yep.
11.
6x plus 11. Yep. Someone else? Yep. 3. And you? 13. Okay. I'll have to make a choice. I mean, you have a 3 here, right? So I'll put 13. That's good. We have 1 and 3. And let's see. I'll put the other one. Just for simplicity so that the numbers are nice. Okay? I'll just choose nice numbers. Okay, great. Let's look at this function. What is the domain of this function? What is the domain of this function? It's this function, 6x plus 11 over 13. May I have an inconsistency over my x's? This function is defined for all x different than 2. Now, is it continuous everywhere on its domain? Is this function continuous everywhere where it's defined? Wherever it's defined, it's continuous, right? So, what is the only possible vertical asymptote? X equal to 2, right? Everybody, do you agree? Possible vertical asymptote, x is equal to 2. Since, well, I mean, this is not correct, but I think you can write it this way. What is it? 6x plus 11, 13x minus 2. It's continuous on its domain. What is its domain? Which is x such that x is different than 2. Okay? Now, I need to find one of the limits of as x approaches 2. What is that? What do you prefer? X approaching 2 plus or 2 minus? Sorry, 26 here. Yeah. What do you prefer? X approaching 2 plus or 2 minus? 2 plus? Let's do that. Now, if x is approaching 2 plus, where does the denominator go to? Numerator, sorry. It goes to something positive, right? The denominator, where does it go to? It goes to 0. Now, what can I say about 13x minus 26 if x is approaching 2 plus? Is it strictly bigger than 0 or smaller than 0? strictly bigger than 0. It's going to 0 while remaining strictly positive, right? So I have a positive number over a 0 plus. What is that? A positive infinity, right? You guys see that? I mean, I think a lot of people are used to write this, but I don't really like it, but I think you can use it. Okay, a lot of people write this as, what is that? So, I mean, a positive number, so it's 6 times 2, 12, so 23 over 0 plus. Okay, a lot of people write this. I don't know, did you used to write this? Yeah? 23 over 0 plus is positive infinity. Okay? Did you ever write this before? What did you do? What is the thing that you did? You just eyeballed it, like you just like looked at it and said this is infinity? Okay, yeah, you can do that. I mean, you know. Yeah. Okay, technically because okay, as x approaching 2 plus. Okay, I don't like that, but that's fine. Okay? Great. So the line x is equal to 2 is a vertical asymptote to y is equal 6x plus 11 over 13x minus 26. Okay, great. Now, let us look at the horizontal asymptote. For the horizontal asymptotes, I have to check the limit as x goes to plus infinity of 6x plus 11 over 13x minus 26. Plug in, what do you get? Infinity over infinity, right? What is that? It's an indeterminate form. What you're just doing here? What is the dominating term on top? The what? 6x, right? The x, right? Everybody. The dominating term on the bottom? X, right? So let's factor an x out from the top. And let's factor an x out from the bottom. Okay, can we spot it immediately? I can cancel the x out, right? 11 over x, where does it go to? 26 over x, as x goes to infinity. What am I left with? 6 over 13. Great. Now the limit as x approaches minus infinity is also the same. As x is going to minus infinity, is also the same. Same argument. 13x minus 26 is the same argument. So the line y is equal to 6 over 13. Is a horizontal asymptote to y is equal to what? 6x plus 11. 13x minus 26 at plus infinity and minus infinity. Great, let's do one more, or let's do a couple more. Okay, can I, yes? Yeah. Yeah, please. You cannot do that. Okay? You have to show your work. Okay? Any questions? Any questions? Yes?
So when the
guys, yeah?
definition of orthogonal asymptote is L is infinity, then it's an asymptote.
It's not an asymptote. Y is equal to infinity is not an asymptote.
Right.
Okay. Should be a number. Any questions? Yeah?
When we're answering a question like
Guys,
that,
yeah?
when we're asking a question like this in assessment, do we need to show all of this proof and say, like,
Of course.
okay,
Of course.
everything needs to be written
Yeah, of course. Questions? No, let's move on. Can I write here? Can I write here? Okay. Oh, I'll just lower this one down. Okay. Let's see. So y is equal to, let's see. Okay, let's look at this function. What is the domain of this function? It's defined for any x where e of x is different than 0, right? Everybody, we agree? Where x is different than 0. E of x different than 1, x different than 0. What are the possible vertical asymptotes in that case? X is equal to 0, right? The line x is equal to 0 is a possible vertical asymptote. Any other value of x, it's not, because the function is continuous everywhere on its domain, right? Yes. X to e of x. This means the function extends x to e to the x minus 1. Over e to the x minus 1. It's continuous at every number in its domain. What is its domain again? This is set of x such that x is different than 0. So the possible vertical asymptotes is the line x is equal to 0. Let's check that. Which side do you want to go? 0 plus or 0 minus? Let's go to 0 plus. E to the x as x approaches 0, where does it go to? 1, right? Everybody. The bottom, where does it go to? Where does the bottom go to? 0. Okay, now I have to determine. If x is approaching 0 while remaining positive, is e to the x strictly bigger than 1 or strictly smaller than 1? Strictly bigger than 1, right? You see that? Let's draw the curve y is equal to the x. Right? If x is approaching 0, e to the x will approach 1 while remaining strictly positive, right? Everybody? Sorry, e to the x will approach 1 while remaining strictly bigger than 1. So e to the x minus 1 will approach 0 while remaining strictly positive. What is this limit then? I have 1 over 0 plus. What is that? Positive infinity, right? Let me write this 1 over 0 plus. Okay, this is not good. Anyways, but yeah. So the line is a vertical asymptote to y is equal to e to the x. Sorry about that, maybe you can't read, but this is the... Now let us check the horizontal asymptotes. I have to check two limits, at plus infinity and at minus infinity. And let's go to plus infinity. What is that? On top, what do I have? E to the infinity is what? Everybody. On the bottom, what do I have? Infinity over infinity. What is that? That's an indeterminate form. So I have to do something. Now, what is the dominant term? On top, there's only one, right? What is the dominant term on the bottom? E to the x. So let me factor e to the x out on the bottom. And then I cancel them out, right? Everybody, is that good? What am I left with on top? 1 over 1 minus 1 over e to the x. E to the x goes to infinity. So 1 over e to the x goes to 0. So this limit is equal to 1. Y equal 1 is a horizontal asymptote at where plus infinity or minus infinity? Plus infinity. Very good. Now let us evaluate the limit at minus infinity. What is that? Where does the top go to? E to the negative infinity, what is that equal to? 0. On the bottom, what do I have? On the bottom, everybody, negative 1. So I have 0 over minus 1. What is that equal to? 0, right? Since right? So the line y is equal to 0 is a horizontal asymptote to y at minus. Okay? Everybody, are we good? Pardon me? Oh, yeah, sure. Let's see what it looks like on a graph. So y is equal to 0, just a second. It's positive, this is negative, it's negative. You know, it's a bit difficult to sketch, right? It's not easy to sketch. Yeah, I think you'll get something, a negative function. Right? I mean, you will get y is equal to 0 and y is equal to 0. Looks like that. May look like that, right? I'm not so sure. Does it look like that? Anyways. Okay, great. Let's do one more. Show that the line y is equal to 0 is an asymptote, is a horizontal asymptote to y is equal to sin x over x at plus infinity. I mean, 2 at minus infinity, but this is 2. So really, what do I have to find? What I have to find is the limit as x goes to infinity of sin x over x. What's the first thing I try? I try to plug in. Does the limit as x go to infinity of sin x exist? Let's look at sin x. It keeps oscillating, right? Do I have a limit as x goes to infinity of sin x? No. Now, so can I plug in? No. What's a good way to do that when I have something? Yes, sir? The squeeze theorem. What can I say about sin x? Sin x is between negative 1 and 1. Now, if x is approaching plus infinity, is x positive or negative? If x is going to plus infinity, x is positive or negative? Positive. So I can divide by x, right? And keep the order. You agree? Everybody, do you agree with this? Since x is positive, as x goes to plus infinity. The limit of the left-hand side is what? everybody, as x goes to infinity, the left-hand side goes to, the right-hand side goes to, so the middle must go to 0. Since then, by discrete theorem, sin x over x is 0. So the line y is equal to 0 is a horizontal asymptote to the curve y is equal f of x to y is equal sin x over x at plus infinity. So the line y is equal to 0 is a horizontal asymptote to y is equal sin x over x at plus infinity. Now notice something, that if you sketch this graph, you know, okay, if you sketch it on your calculator, it would look something like that. But this curve crosses the asymptotes infinitely many times, mainly at every integer multiple of 5, right? So what is sine 1005 over 1005? 0, right? Sine of 2000, yeah, sine of 2005 over 2005, what is that? 0. How many times does this curve cross the asymptote? Infinitely many times, okay? So if you have a horizontal asymptote, it doesn't mean that the curve does not cross it. Okay? Great. Now we're done with this. We'll move on to an important part. Maybe we do one more asymptote. We do one more, or that's fine. Should we do one more? Yes. Let's do one more. I mean, I'll give you the answer. I'll give you. This is from the book. Okay, what do I need to do here? This function, where is it defined? It's defined, let me factor an x squared out. It's defined as domain, what is its domain? As domain x, x and x is different than 1. You agree? I'm going a bit fast. I'll leave you the details to work out, okay? I'm just giving you like some nice things. Now, what are the horizontal asymptotes here? Let's go to limit as x goes to plus infinity. So what are the possible vertical asymptotes? X is equal to -1. X is equal to 0, and x is equal to 1. Let's check that. If x is approaching 1 plus, what can you say? Where does the top go to? The top goes to 2, right? The bottom goes to 1, this term goes to 1, that's nice, right? I have 2, and then I have 1. Now 1 minus x squared will go to 0, do you agree? Now if x is bigger than 1, what can you say about 1 minus x squared? It's negative, right? If x is bigger than 1, then 1 minus x squared is negative. So I have 2 times 1 times 0 minus, so what do I get? Minus infinity. Okay, let's look at the limit as x goes to 0 plus. Where does the top go to as x goes to 0 plus? 1, you agree? Where does the bottom go? The bottom goes to 0, of course. This one goes to 1, and this one goes to 0. Now x squared is a positive or negative as x approaches 0 plus? Doesn't matter whether it's 0 plus or 0 minus, but what is it? Positive. So I have, say, 1 over 0 plus times 1, what is that? Plus infinity. Oh shoot, this is plus 1 here. Okay, and I'll put a minus 1 here. And let's put as x approaches minus 1, let's say plus 1 plus x4. Can you try to work it out? So the top goes to 2, right? This one goes to 1, so I have 2 over 1. Now, if x is slightly bigger than minus 1, what can you say about 1 minus x squared? It's positive, right? Right? You see that? Draw your parabola. This is minus 1 here. If x is very close to minus 1, then x squared is less than 1, right? You agree? Yeah. I mean, it's approaching minus 1, okay? So this is 2 over 1 over 1 minus x squared is 0 plus. What is that? This is plus infinity, okay? So these are the vertical asymptotes. And what are the horizontal asymptotes? I'm going to give them to you. Horizontal asymptote is the line y is equal to minus 1 at plus infinity and minus infinity. Check it. Okay? It's an easy question. Do it. Okay? Great. Now, let's move on to the formal definition of element.
One quick question.
Yes, sir.
Do we have to check for both sides of the system or only one side?
The horizontal asymptote or the vertical?
Horizontal.
Yes, of course.
But then vertical, we only have to check one side.
Exactly.
Okay.
Horizontal is not side.
Yeah.
A different direction. Exactly. Guys, yeah? Yeah. Could be minus. Could be x goes to 0 minus. Okay? You can still do it with the same thing. X goes to minus 1 plus minus 1 minus. Well, the answer may be different. You may have minus infinity, or you may not have. Okay? Is that clear? Yeah. No, I said the horizontal asymptote is y is equal to minus 1. You have to check it. Okay? Great. Now let us move on to the formal definition of element. Okay. So if f is a function, if f of x is defined on an open interval containing A except at possibly A, we said that the limit as f of x approaches A of f of x is equal to L if what? What did we say? If f of x can be made arbitrarily close to L by making f sufficiently close to A but not equal to A, right? Now what does this mean in a mathematical way, in mathematical terms? if for every epsilon positive, there exists delta positive, depending on epsilon, of course, such that implies oh wait a minute. We say limit as n approaches a of f of x is equal to L if for every epsilon positive there exists a delta positive such that if x minus a in absolute value is less than delta and strictly bigger than 0, then f of x minus L is strictly less than epsilon. What does this mean? So far it means nothing maybe, but let us try to make sense of this definition. It says that f of x can be made arbitrarily close to L. What does this mean? Like if I give you an epsilon, let's say 10 to the minus 2, I can make f of x 10 to the minus 2 units away from L. This is what this means. By making x sufficiently close to a but not equal to a. By making x sufficiently close to a but not equal to a. Okay? It's a bit difficult, but let us do a definition. Let us find something. Let us do an example. What is the limit as x approaches to of, let's say, x minus x plus 5? What is this? 7, right? Let us prove this using the epsilon delta definition. Of a limit. What is my L in that case? 7. And what is my f of x? X plus 5, right? N is equal to 10. Great. Now, so let epsilon be positive. What is f of x minus L? It's x plus 5 minus 7, right? In absolute value, it's x plus 5 minus 7, which is x minus 2. This is a very obvious problem. Now, if I want x plus 5 to be within, let's say, 1 unit from L, okay? If I want this difference to be strictly less than 1, okay? Let's say you want this difference to be strictly less than 1. How should you take x minus 2? X minus 2 should be less than what? 1, because this difference is equal to x minus 2. You agree?
Yeah.
If you want this difference to be less than epsilon, how should x minus 2 be? Less than epsilon. You agree or not? So what is your delta in that case? Epsilon, right? So, if delta, let delta be equal to epsilon, if 0 x minus 2 delta, then f of x minus L, which is equal to x minus 2 in that case, is strictly less than delta, which is equal to epsilon. Then the limit as f of x as x approaches 2 We'll do one more. We'll do two or three more. Okay, let us do one more. Okay, let us show that limit of 2x plus 1 as x approaches 4 is 9 using the epsilon delta definition. So I gotta make 2x plus 1 arbitrary close to what number? To 9 by making x sufficiently close to but not equal to 4. Great. So let f of x be equal to and what is L in that case? L is 9. What is f of x minus L? F of x minus L is 2x plus 1 minus 9, in absolute value, of course, which is 2x minus 8. Can I factor a 2 out here? Yeah? Can I factor a 2 out? If I factor a 2 out, I get it's the absolute value of 2 times x minus 4. You agree or not? Now, if I want to make this difference less than epsilon, okay? I want to make this less than epsilon. So by making x minus 4 less than delta, what should my delta be? So I want this 2 delta, right? If x minus 4 is less than delta, and I want the difference to be less than epsilon, what should my delta be? Let's say you want this equal to epsilon. What should your delta be? Epsilon over 2, right? Let epsilon be positive. I mean, this is and set delta is equal to epsilon over 2. If x minus 4 is less than epsilon over 2, then what can you say about f of x minus L? What is f of x minus L equal to? It's equal to 2 times x minus 4, which is strictly equal to 2 times delta, which is 2 times epsilon over 2, which is epsilon. Hence, okay, so we'll continue more with these examples on Wednesday. It's a bit tough, it's not easy, but that's the best part of the course, okay? Yeah.